Today we are going to talk about the Pythagorean theorem, lesson 1 in unit 5. Now understand that I know that all of us have dealt with the Pythagorean theorem and used it before, and we even used it in the last section that we talked about as it related to geometric means. But we're going to get a little more in depth of what the Pythagorean theorem actually can do for us. So we're going to use the Pythagorean theorem. We're also going to use the converse of the Pythagorean theorem, and we're going to classify triangles using the Pythagorean theorem. Okay, so most of us, if not all of us, know that in a right triangle, the sum of the squares of the legs equals the hypotenuse squared, if it's a right triangle. Now, most of you memorize it as a squared plus b squared equals c squared. Well, that's true, but you better know what a, b, and c are. A and b are the legs, c is the hypotenuse. Now, you may not know this. A Pythagorean triple is a set, is a set of positive integers, a, b, and c, that satisfy the Pythagorean theorem. So these integers are unique, in other words. So like 3, 4, 5. 3 squared plus 4 squared equals 5 squared. So we call that a triple. 5 squared plus 12 squared equals 13 squared. We call that a triple, etc. These are the main triples that we deal with. 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Now there are others for sure. But there also are all the multiples of them as well, like 6, 8, 10, or 9, 12, 15, and 10, 24, 26, etc. So these are just some of them. There's literally infinite number of triples. But this just can sometimes be a shortcut for us when we're dealing with right triangles. So using the Pythagorean theorem, we're going to set this one up. Let's see, we're supposed to find x. Well, what is x? Well, x is the hypotenuse. So leg squared plus leg squared equals hypotenuse squared. So 25 plus 144 equals x squared. That's 169. We undo the square by taking the square root, and we get 13. So that is a triple, 5, 12, 13. And that was one of them back here, right here. So that's why it's called a triple. Now let's see if this is. Well, what's x this time? It's a leg, isn't it? So 7 squared plus x squared equals 14 squared. Now it doesn't matter where we put 7 and x with our legs, but it does matter with our 14. It has to be the hypotenuse. So then we would subtract 49 instead of adding. We have to subtract, and that's what, 147, I believe. And then we take the square to run 147. Well, that definitely isn't a real number, an integer, I should say. Let's see, what goes into 147? 49, I think, 3 times. So this is the square root of 49 times the square root of 3, which is 7 radical 3. So we've seen that before, haven't we? 7 radical 3 is also approximately 12.2. So that is not a triple. That is the side length, though. That is the leg length. And that is a 30, 60, 90, isn't it? Because short leg, long leg, 7 radical 3, and the hypotenuse is double the short leg. Okay, now, there's many uses to the Pythagorean theorem, and here's one of them. We need support beams between these two buildings for this walkway. Well, the walkway span is 23.26 meters. That's quite a ways. And so we need to know how long these support beams will be. Well, what are those support beams? Legs or hypotenuse? It's the hypotenuse. So 47.57 squared plus, now, that's going to be only half of 23.26 because 23.26 is the whole distance across, so we're going to divide that by 2, and it's 11.63 squared equals x squared. So I'm going to square these and add them because the numbers are so big. We get 2398.1618, and we take the square root of all that, and we end up with about 49 meters. Okay, that's how long those support beams would be. So there you go with an application of the Pythagorean theorem. Now, we just did 3 things, and that's what we're going to do right here. We're going to check our understanding of the Pythagorean theorem. So I want you to pause it and do these 3 problems. Okay, you're back. So the first one, we're looking for the hypotenuse, and that is going to be 52, and the square root of 52 is 4 times 13. So 2 radical 13 is the exact answer. And if we put it in calculator, approximate form, it'd be 7.21. Okay? If we know our triples, x is 4, 3, 4, 5. If not, we have to use the Pythagorean theorem. But here's the nice thing. If we know our triples, we can find shortcuts like that and just know that that's 4. Number 3, an anemometer is a device used to measure wind speed. And you've seen these before, especially at airports, especially small airports. It's on top of a pole, and we have support wires that are attached to the pole 5 feet above the ground, and each support wire is 6 feet long. Well, 5, 6 is not a triple. The hypotenuse is 6, the leg is 5, we're supposed to find the other leg, which is d. So d squared plus 5 squared equals 6 squared. So what's that? 11 when we subtract 36 minus 11. So d squared equals 11. So what is d? Well, square root of 11 is about 3.3 feet. So again, we're applying the Pythagorean theorem. Now, the converse of the Pythagorean theorem says if a squared plus b squared equals c squared, then we have a right triangle. So we can also go the other direction. So is this first one, is that by using the Pythagorean theorem, is that a right triangle? Well, is it equal? I don't know. That's what we're going to find out. So 81 plus 225, well, what's 3? So we're going to put this in our calculator. 3 radical 34 in parentheses. And then we're going to square it. And we get 306. Is that equal? Well, that's 306, isn't it? So, yep, that is a right angle then. So that's how we use the converse. Okay, so is that one a right angle? Well, 14 squared plus 22 squared equals 26 squared. Now, how do I know that 26 is the hypotenuse? It's always the longest side. That's how I know. So 22 squared is 484. 26 squared is 676. Those are not equal, are they? 484 plus 196 is 680. So 680 is more than 676, so this is not a right triangle. Okay? So that's how we can use the converse. Now, I want you to pause it. Oh, what do you know? That's the same slide. All right, good job. Same slide. Let's go to the next one. Okay, now, we can also classify those triangles. So let's say that we're going to check to see if they're right angles, but we could also see if they're acute or obtuse. If it's acute, the hypotenuse squared is less than the sum of the legs squared. But if the hypotenuse squared is more than the sum of the legs squared, it's obtuse. Huh, interesting. Bet you didn't know that. So, classifying triangles. Verify that segments with lengths of 4.3 feet, 5.2 feet, and 6.1 feet form a triangle. All right, well, first of all, we have to check to see if these measurements form a triangle. How do you do that? You take the smallest two sides, and they have to be bigger than the third side. And in this case, 4.3 plus 5.2 is definitely bigger than 6.1. So now we can use the Pythagorean theorem. So I know that the two legs have to be the smallest sides. We want to know, is that true? Is it equal? So 4.3 squared is 18.49. 5.2 squared is 27.04. And 6.1 squared is 37.21. But I know already that 27 plus 18 is 45. That's bigger than 37. So this symbol is going to be greater than the hypotenuse squared. I think it's 50, let's see, 45, sorry, 0.53, and that's greater than 37.21. Since it's greater, it's obtuse. So this triangle is an obtuse triangle. Okay. 3, 4, 5, 6. 3 plus 4 is 7. 7 is bigger than 6, so it is a triangle. So we want to know 9 plus 16. How's that with 36? Well, that's definitely less than, isn't it? 25 is less than 36. So this is an acute triangle. 2.1 and 2.8 add up to 4.9. That's bigger than 3.5. So this is a triangle as well. Let's see what kind of triangle it is. And I'm just going to add them together. That's 12.25. 3.5 squared is 12.25. What do you know? They're equal. So this is a right triangle. So we have an obtuse triangle, an acute triangle, and a right triangle. That's how we classify triangles. Now, that is the end of the lesson. Click on to Canvas and go on to the next assignment.